Hello and welcome to the Intel Network and Edge panel on breaking up 5G AI islands through customer centricity and developing a true E2E AI deployment model for 5G. I'm Guy Daniels, Director of Content at TelecomTV. Well, joining me now to discuss how we can build an integrated approach that will link these seemingly disparate islands of AI are Lynn Comp, Vice President, Data Platforms Group and General Manager, Visual Infrastructure Division at Intel. Nate Rowe, Team Leader and Creator of SKT Lightning Database Solution at SK Telecom. Subhash Chopra, Director Technology, Solution Leader 5G O-RAN Network AI and Industry 4.0 at Capgemini Engineering. And Yuran Dude, Vice President of Business Development and Product Marketing at Cellwise. Hello everybody, good to see you and thank you all for taking part in our roundtable. First question I'd like to ask is, why is 5G different from the previous cellular generations? Can you share key network AI use cases and also where you see AI play a key role? Lynn, let me first ask you to introduce this topic and address those initial questions.
Absolutely. Thank you, Guy. Good to see you. So one of the first fundamental aspects that we have to keep in mind is how different 5G is as a network and as a network standard. We've had a lot of work in the industry leading up to this point where we've gotten off of more purpose-built hardware-centric capabilities into something that is more network function virtualization and cloud-native networks. And 5G itself is a completely different standard. Not just voice, it includes ultra high definition mobile broadband, it includes massive infrastructure for Internet of Things, and it includes highly or low latency use cases. And so 5G drives a lot better TCO and efficiency for the three major use cases. And then it also has a lot more flexibility in terms of the kind of network that is presented for all of these use cases. So it creates a number of new business opportunities and a new set of capabilities in the network, bringing in AI in many forms on that base that we've been building since the 2011 timeframe when we started with NFV in the core infrastructure of the network.
Thank you, Lynn. And Yuran, AI and automation play key roles in 5G.
Indeed, thank you, guys. 5G itself and its new architectures, as well as the evolution towards the Open RAN vision, introduces new components, a host of new players, and getting all that tied in has to be is definitely complex and is going to lead to the need for intelligence, which will come through AI. And no doubt that 5G of its own, in order to become customer-centric and enable all those SLA-driven propositions, is going to require the combination of massive MIMO and beamforming and the disaggregation to enable these dynamic services. And all of this has to be orchestrated alongside existing assets in the form of previous Gs that all have to support these new services. There is no doubt that AI is not one size fits all, and it's going to be distributed across the different layers within the stack. Tying them in together will definitely create significant benefits for our customers.
And Nate, what experiences can you share with us?
Our 4G support, SK Telecom had 400,000 cell towers with over 27 million subscribers. This network handled 1.4 million records, logs every second, which accumulated to 120 billion records per day. I think with 5G, I expect this data volume will be increased much bigger, and actually more cell towers are being built right now, and I think the data volume will be exploded. So from that point of view, I think building fast and scalable big data and AI architecture getting more important to efficiently handle this infrastructure.
Thank you, Nate. Well, let's move on and let's ask our next question. That is, what challenges do operators face as they embrace AI to seek efficiencies and drive new growth in the industry? Ewan, let me ask you that one first.
Key thing to any AI or ML technologies is data, and making sure that it's available for consumption. The industry is going towards a path of standardizing data and standardizations, but that's still lacking. And in order to get that really driving at scale, we need to standardize it. And if we're looking to train a model and reinforce it and really create impact, we have to have consistent, low latency availability into that data itself. Another key challenge is, how do you measure? I mean, there's fantastic ideas, there's great scientists and great engineers, and there's great thinking or blue sky thinking. How do you get that actually implemented? And when we're looking at production networks, it's not a trial and error. You got to get it right. There's millions of customers, as Nate just mentioned, that are actually consuming these services. So deriving the insights and leveraging the impact is key. But that's all technology aspects. There's actually another key factor, and that is the skill sets, which are typically fragmented or even missing in certain organizations, and bringing them together. Understanding AI and ML techniques and technologies doesn't mean that you understand the domain that you need to apply it into. And coming from Selway's point of view, specifically the RAN domain, data scientists are data scientists, and RAN engineering is RAN engineering. Bringing that closer and closer together is what really is going to be critical. The solution is, of course, to actually bridge the gap and create the infrastructure that is required.
Yeah, very interesting. Thanks for those comments. Lynn, please.
I just wanted to add on to that the reality for the business that the network operators actually run. To Yoran's point, it's absolutely critical to be able to have the trained models and have them in the right place. And one of the unique things about network AI is the fact that much of the architectures that have been put in place in other commercial realities, other commercial models, don't actually fit the distributed nature of the network. So there needs to be some tuning to the application, per Yoran's point. The other important point on this is that the operators are paid to move data. And so there have to be rethinking and tuning of the assumptions about how much of the pipe is dedicated towards getting the data back for network operations and for AI, and how much of the network is actually doing what it's supposed to do, which is connecting people and giving access to 5G data. So there's also a business component to this, to Yoran's point about how do you actually bring AI into the network aware and the network context in a way that's sensitive to the business for the network operators and helps them unlock the potential behind 5G.
Yeah, thank you very much. That's very important. Thanks, Lynn. Subhash, what challenges are you seeing now?
The thing is, like, there is a quite radical shift which has to be there in the mindset of operators, because today when we are looking into application of AI, although that shouldn't be termed as network AI here, but those things are more talking towards those scenarios which are more user centric and coming from BSS and revenue realization perspective. So if we talk about scenarios where we are like focusing as an operator today, even if it is Vodafone, SK Telecom, or any world's biggest operator, they're talking about how I can assess the way customers are experiencing my new offerings, what is leading to the customer churn, how can I improve customer stickiness. But now the shift is towards making those networks themselves more autonomous. They should have their brain in themselves. So we are talking about that AI which is fitting inside the network as a brain. So there is where now what we need to do, as my other colleague was telling, it is not about AI, it is about bringing two things together, which is a network domain knowledge as well as our AI and machine learning, and that to oriented toward making those networks more intelligent, having some kind of a brain in that network, making them more autonomous in their operations. So as my colleagues were rightly mentioning, the challenges around data, turning around, training the models, and then even ensuring that those are working as expected. That even requires things like what we were showing in the slide, that there is the need for an ecosystem which has all those things which is today there for like those software development things and coming into network, which we term as DevOps. Similarly, we need to have something which is called MLOps. So we need to operationalize machine learning and artificial intelligence and to ensure that things are performing as they are expected. As the slide was mentioning, that framework coming from Capgemini, which is called Net Anticipate 5G, which is even focusing on implementation of those use cases which are more network AI centric, and then providing all those engines which can help the CSPs to do those things and bring them to this domain as quick as possible and onboard them to this ecosystem. And so we provide all these different things to ensure they are onboarded and they are smoothly transitioned from their current state of application of AI into networks to the newer state where things are more network centric than rather user centric. And there needs to another reorientation from being a network equipment provider centric to more like collaborative environment where it is not only network equipment provider but also others like system integrators, those chip vendors, and people like Cellwise and Intel and ARM, and everybody collaborate and they know what is the knowledge stored in what part of that network, so that that can be assimilated in those intelligent models, and then those brains can be effective in their decision making.
And Nate, what other challenges do operators now face?
I think that in order to develop practical network AI solution in telecommunication companies, we need balanced skill sets in networking and big data and AI. So people who knows only AI without networking domain knowledge will develop focus on only AI models. And we also need to know how these AI models help network operation, configuration, and optimization. And lastly, big data is also very important skill set because we need to consider entire AI data pipeline from the data collection, data transform, pre-processing, and training and inference. However, this is very limited cases.
Thanks, Nate. Lynn, there's a lot for operators to do with here if they want to successfully implement network AI.
Bringing AI and the network together in one domain, honestly, there's an opportunity to do that built on the infrastructure that has been deployed for 5G that really has the basis of network function virtualization and general IA processors underneath, because a lot of the AI capabilities start out running on a CPU. And, I think one of the things, just to give you a range of some of the use cases in the network that don't require these really complicated, really wide, deep models to be able to function and add a benefit, are things like inserting AI into the 5G vRAN layer 2 stack, and that can allow you to get better spectrum efficiency, for example. And then even beyond that, you saw some of the capabilities from Cellwise as it grows, as the O-RAN standards start to roll out, that bring even more and more automation and more network-aware models and network-aware applications that can be presented.
Thank you. Well, I'd like to ask you all if you can share examples of AI-powered solutions that provide operator benefits, such as CapEx, OpEx, network efficiency, or users QoS. Subhash, let me get your views first.
Yeah, so very well stated question. And Lynn just now mentioned about one of those use cases where she has mentioned that applying machine learning to layer 2 in vRAN has helped operator achieve a better spectral efficiency. So that is one of the key use cases which we have even tried in collaboration with our ecosystem partners. And as we see today, like if we talk about ORAN, what is it doing today is a big ecosystem of all operators network equipment providers, those chip vendors, and even system integrators. So if you see here in this slide, even so, what I'm telling is like in our company as well, we are positioning ourselves as not as a system integrator, but as an ecosystem provider nowadays. So like we are bringing together some solutions, we are bringing together 5G stacks, and then we are bringing together all the partners so that we can realize those use case to happen. Like as Lynn mentioned, one of the cases where we were like having collaboration with Intel team as well as a few others, and we did that realization of the use case in layer 2, wherein we were able to achieve like around 15% increase in the spectral efficiency, which is a big number. And if we talk about those two operators, they'll say, wow. And similarly, we're talking about similar use cases in MIMO, massive MIMO, multi-user MIMO. And there also we have a big ecosystem where operators, those cloud providers, interestingly chip vendors, and even people like those orchestrators and those BSS, OSS, we all are collaborating together. So that is the key message which I like to pass to everyone, that this is not now a monolith system where we would be more NEP centric. Rather, we have to reorient ourselves, and we now need to make a stronger ecosystem and work together. And there we would need players like Capgemini, who are bringing that ecosystem providers, and then bring it to reality.
Thank you. And Yuran, any insights that you can share with us?
Yeah, indeed. First of all, I echo what has been said here. I think one of the reflecting on our opening question, it's an ecosystem, and that means that we have to be in a collaborative mindset, which we all bring pieces of the puzzle, whether it's Intel, whether it's Cap, and cell-wise, 95, 96% of the market has existing assets. We have to tie those in. We have to make sure that we bring as much intelligence as possible into 5G, but also trying to maximize the utilization of existing assets. And this is true across the life cycle of introduction of nodes, whether it's looking at day one use cases, which I primarily automating the deployment orchestration. And when we're looking at vRAN and later on Open RAN, it's no longer just plugging in a full stack rec and be done with it. It is much more complicated. There's much more moving parts, and leveraging AI in combination between Cellwise and Intel FlexRAN definitely drives those benefits forward, allowing for carriers to retain the lower capex point of this entire Open RAN ecosystem, but also ensuring that the low capex is maintained or achieved with a much faster time to market.
Thank you. And Nate, what can SKT share with us?
SK Telecom have built our own in-house database system solution as real-time in-memory data analytics solution. And we apply this solution to network quality analysis and geospatial visualization for floating population analysis. This solution provides real-time analysis of key network KPIs, such as radio cell tower resource allocation or radio quality, etc. So by building this in-house solution, we have resolved our CapEx and OpEx by executing DevOps in our company.
Thanks, Nate. Well, you mentioned KPIs there, and I'd like you all, if you can, to elaborate further on what critical KPIs are required in your AI solutions and how you brought AI hardware and software technologies to meet this requirement. Subhash.
So for that, the kind of KPIs which will come into play is, first of all, to ensure whatever we are stating as those intelligence and those brains of the network are capable of running in the existing infrastructure in place in those networks. So that is one of the key here, that how well we can train our models, how well we can think about our applications to run on those brownfield deployments without any need of new hardwares like accelerators, GPUs, or even enhancing those hardware as they stand now in the network. How well we are able to encapsulate the knowledge from the network, and how well those knowledge are being expressed in the inferences, that too well in time. Because when we are talking about network AI, we are talking about those use cases which are running in few milliseconds, even of the order of more less than 10 milliseconds. We have to see how well we can sit on the existing hardware, how efficient we are in terms of time of inference, what is our memory footprint, what is our CPU utilization, and how can we fit ourselves in the current COTS hardware which is in there or which is planned for those ORAN and RIC kind of infrastructure platforms.
Absolutely. And Nate, what was your experience?
As I mentioned earlier, SK Telecom developed very fast in-memory analytics solutions, and SK Telecom used Intel's solutions such as mass kernel library and AVX 512, and yeah, so we made 2 times performance improvement together. And so end-to-end AI pipeline included in big data analytics, and the AI is also very important. Originally, SK Telecom designed CPU and GPU architecture, and data is exported as CSV format, which is text file format, to GPU, and for pandas as a pre-processing and AI inference. But we found the performance bottleneck happening in data export and pre-processing. So we used Intel Analytics Joule pipeline solution to build in-memory data pipeline. So we are able to unify TensorFlow model SRAM into Apache Spark open source based query engine. And so this was a great success with Intel collaboration. So in our tests, end-to-end latency was improved 3 times. Also, this architecture provided cluster serving to distribute this pipeline into multiple CPU servers. So we achieve scalability as well.
Now, what are some of the key lessons that we can learn from AI adoption in telecoms so far? And Nate, let me start by you. What are your main lessons?
In my experience, first one is about AI model scalability and management. In our company's example, we have 400,000 cells, and each of them have a different pattern of data, and the AI should train for them for each different pattern. So for the specific model, we need a specific AI model for the different patterns. Then it will require more computing resources to train them. So, and it also requires much more hardware cost. And it is very difficult to manage too many AI models for training and inference. So first, we need to develop scalable AI model which can comprehensively handle the multiple cell towers together with better accuracy. And second, performance optimization is also important. As I shared previously, Intel SKT proved unified big data analytics and AI pipeline, improved end-to-end latency by 3 times. So I think Intel Analytics Joule pipeline library is a great solution in terms of seamless pipeline integration without changing deep learning or Spark data cores. And I'd like to keep working with Intel for the further optimization with more Intel AI libraries and Intel's new Xeon CPU architecture. I think Intel is pioneering this area and leading the technology. I mean, specifically for the in-memory AI data pipeline and end-to-end data pipeline.
Thank you, Nate. And Jeroen, key takeaways from you?
We are in an interesting time. From a RAN perspective, there's an interesting journey that we're all embarking from all sides of the equation, moving from the traditional RAN initially towards vRAN, and finally reaching that end state of Open RAN. The different layers that are evolving here are introducing the different components of AI techniques, technologies, and capabilities that will enable this, from the hardware chipset layer with built-in accelerators from Intel, moving upwards in the stack with FlexRAN, AI, ML based radio resource management to enable this vRAN journey. And then, as mentioned by my colleagues here, the other layers of management and orchestration of the RAN in the form of near real-time RIC, where AI ML models will have a key role of execution, mainly inference. And as we move up into the stack towards the non-real-time and service management and orchestration, where AI models will have to be trained, and there will be inference as well in non-real-time as we're seeing significant impact. And I'll just leave it with a statement I've made throughout this panel. There's existing assets, and if there's one thing that we have to aspire for, is to bring as much intelligence as possible also to the existing assets, because these are capex investments already made, and everything has to coexist to the best extent possible for the benefit of our customers.
Quite right. Yes. Thank you, Jeroen. And Subhash, final observations from you?
As we are talking here about those greenfield and brownfield operators, that we have to be cognizant of the fact that we need to run on those already available infrastructure, and Intel is playing a very vital role there. That we now, when we were doing those collaborative activities along with Intel, we realized that many of those deep learning models no more now need GPU to even train or do inferences. With newer instruction sets introduced by Intel in their recent Cascade Lake and Ice Lake architectures.
Thank you, Subhash. And Lynn, can you summarize and leave us with the main lessons we've learned to date from AI adoption in telecoms?
One of the important things that we want to bring into that is that the network AI model, in many cases for network operations, isn't the complex wide models, and it's not necessarily going to operate the same way because it isn't doing recommendation engines in a hyperscale environment. It's actually having to be flexible on the network architecture that's designed for the operating reality of each operator. And so that's one of the main reasons why all of our investments in open source AI tools and libraries, collaborating with companies such as on the panel today, and participating in the industry network group gives us the opportunity to take all of those learnings from the reality of high frequency, lower density or higher density, smaller cell sizes, mountains versus desert, and be able to offer network AI use case reference modules. And that helps simplify the AI adoption in the network domain. And that brings the whole ecosystem together, because there's a lot of these use cases where you find you need to keep the data close in memory. You really cannot be separating it out to a special purpose instance. So I think that that's one of the main learnings that we've come to, is we have to have the ecosystem. We have to keep having open source and open access AI tools and libraries. It needs to come through the standards bodies. There needs to be more standards. And the industry has this exciting opportunity, once again, to learn together on how do we apply these new capabilities to the operational reality for the network operators and for 5G.
Well, that brings our discussion very nicely to a close. Thank you everyone for taking part today and sharing your views and experiences. That was our panel on breaking up 5G AI islands through customer centricity, developing a true E2E AI deployment model for 5G. Be sure to watch the other discussions that are part of the Intel Network and Edge panel series. You can find full details right here on the website. For now though, thank you for watching and goodbye.